Good morning, students. So today we are going to learn the two theorems of chapter 2 polynomials of class 9 from NCERT book, and the name of the theorems are remainder theorem and factor theorem. So polynomials. Now, first of all, we are going to study remainder theorem. Now, what is this remainder theorem? This remainder theorem is nothing but is used to find the remainder of a polynomial, a big polynomial, when it is divided by a small polynomials. In general, that small polynomials is either a linear polynomial or a quadratic polynomial. So basically, previously in our previous classes, we are using that long division method to find the remainder when a polynomial is divided by another polynomial. But here, these theorems, remainder theorems, will reduce our effort of finding the remainder. Instead of doing that long division process, we are simply just putting the values, some values, we are doing some manipulation in the polynomials and we will get the remainder. So, what is this remainder theorem all about? The remainder theorem says that if a polynomial px of degree greater than or equal to 1 divided by another linear polynomial x minus a, where a is a real number, then the remainder is pa. This is the definition of remainder theorem, that if a polynomial px of degree greater than or equal to 1 divided by another linear polynomial x minus a, where a is a real number, then the remainder is pa. Now let's see the proof of this theorem. So suppose when px divided by x minus a, then let the quotient be qx and remainder be Rx. But since our divisor is of degree 1, so the degree of remainder should be always 1 less. Means the degree of remainder should be always 0 for every value of x. So Rx is equal to R for every value of x. Now, after applying the division algorithm, so px is equal to x minus a qx plus r. Now for a particular, in particular, if we put x is equal to a, put x is equal to a, so this PA is equal to a minus a QA plus R. So PA is equal to 0 plus R. So PA is equal to R. Proved. So this is the proof of the remainder theorem. Then when Px is divided by x minus a, where a is some real number, then the remainder is PA. So this method is used to find the remainder. We are going to do nothing. Now in any given polynomial, so I am just taking one example. With the help of example I am going to explain this. So example, given Px is equal to x cube plus 2x square minus 3x plus 4 divided by x minus 2. Now according to remainder theorem, the remainder theorem says when it is divided by x minus 2, then the remainder will be P2. So we are going to do nothing. We just simply find this value of this polynomial at x is equal to 2. So P2 is equal to 2 cube plus 2 square minus 3 into 2 plus 4. So this will give me 8 plus 8 minus 6 plus 4. So this will give me 14. So the remainder will be 14. So we have done nothing. We have just simply put in place of x 2. When this is negative, here we put positive. When this is positive, we put negative. So this is all about remainder theorem. The next theorem which we are going to discuss is a factor theorem. Now what is the use of this factor theorem? Now again, the factor theorem, previously in order to check that a given polynomial, a small linear polynomial, is a factor of a big polynomial, we start dividing that big polynomial with a small polynomial. And if the remainder is 0, then we say yes, it is a factor. Now in factor theorem, it is just an application, we can say, of remainder theorem. Factor theorem is just an application of remainder theorem. In another word we can say. So the factor theorem says that simply if this polynomial is divided by x minus a and x minus a is a factor, then the remainder is 0, and vice versa, means if the remainder is 0, then x minus a is factor. So this will also help to find that whether the given polynomial is a factor of the big polynomial or not. So let's do factor theorem. So the next topic is factor theorem. Now what is this factor theorem all about? The same thing we are going to write here. If a polynomial Px divided by another linear polynomial x minus a, then two cases will arise. The first one, if x minus a is factor of Px, then remainder will be 0. And the second is, if remainder is 0, then x minus a is factor of px. So two cases will arise here. When x minus a is factor of px, then the remainder will be 0. And the other one is, if the remainder is 0, then x minus a is a factor. Again, this theorem is used to check that whether a given linear polynomial is a factor of the big polynomial or not. Again, this simplifies our efforts, it reduces our efforts. Now, let's take an example. So, example, let px is equal to x cube plus 3x squared minus 3x minus 1. When this polynomial divided by x minus a, whether we have to check that whether this x minus a is a factor of this polynomial or not. We are going to do simply nothing. We just put x is equal to 1. As I told in the remainder theorem, when this value is negative, we put here positive. When this value is positive, we are going to put here negative. So P1 will be 1 cube plus 3, 1 square minus 3, 1 minus 1. So 1 plus 3 minus 3 minus 1. 4 minus 4, 0. So since the remainder is coming 0, therefore we can say that this x minus 1 is a factor of this big polynomial px is equal to x cube plus 3x square minus 3x minus 1. So in this manner, we solve our questions which is based on factor theorem and remainder theorem, and the worksheet I'll provide you in the Google Classroom of 9th A. Thank you for today.